Okay, so we're looking at number 19, that's 9.C.44. And it says the half-life of a certain element is about 5,700 years. So lambda is about 5,700. Use the radiometric dating formula to complete parts A and B below, which is what I had just developed in that last little bit there. We're going to say that the time, we'll say the age of this thing is equal to the logarithm of how much we have over the log of 1/2 times that half-life. So for part A, what do we have here? A piece of cloth is painted with organic dyes. By analyzing the dye in the cloth, it is found that only 62% of the certain element in the dye remained. When was the cloth painted? The amount that we have, or this Q naught, you could call it, although it's a percentage, so I'm going to say P naught is equal to 62%. We're going to use 0.62 for that. So again, we'll go into this and we'll say that the time is the log of 0.62 divided by that log of 1/2, or 0.5. And that tells us how many half-lives have passed. And we multiply that by the length of a half-life, and we'll get the number of years. Bring up the calculator. Log of 0.62 divided by the log of 0.5, and then we multiply by 5,700. Oops, too many zeros. 5,700, great. And we'll get that it's approximately 3,900 years old. Three thousand 900 years ago. There we go. Next, we have a well-preserved piece of wood is found at an archaeological site, and it has 12.5% of that certain element, and that's the amount that it must have had when it was alive. Sorry. Estimate when this wood was cut. So in this case, I'm going to take the amount that I have, that percentage that we start out with is 12.5%, which is 0.125. That's a little bit more space. Now, that time is equal to the log of how much we have, 0.125, divided by the log of 1/2, or 0.5, because we're talking about half-lives, times the half-life of this substance, 5,700 years. And we're going to do log of 0.125 divided by the log of 0.5, and we're going to multiply by 5,700, and we'll get 17,100. All right. So 17,100. Yeah. Log of the log is 17,100. What did I mess up? Yes. Yes, I know that. Oh, round to the nearest thousand as needed. Don't change the rules on me, Pearson. It's not fun. Approximately 1,000 years old. I guess the rule was two significant figures, and I didn't catch that. Okay.